let's try to graph the linear inequality. 5x minus y is less than 5. Okay, to get started here, it's really a large two-step process. One is first, we need to graph the line, and then the second is to determine which side of the line we wish to shade. So for the purpose of graphing the line, I'm just going to try to figure out 2 points that are on the line by making a standard t-table here. Now conveniently, because of the way the equation is written, the inequality is written in standard form, I'll be able to replace numbers very easily to figure out some answers or some points that would be on the graph. So if we were to replace x with 0 and pretend that the function was actually equals and not less than, or that the inequality was less than, we would have 5 times 0 minus y equals 5, which would mean that negative y equals 5, which would mean that y is equal to negative 5. So I know for a fact the point 0 comma negative 5 is going to be on the graph. So let me put a dot on the graph right now. Now that's on the border of the graph. Okay? Now pretend that y were equal to 0. Similarly, if we pretended the inequality was an equation, we would now have 5x minus 0 equals 5, which would mean that 5x equals 5, and now x is equal to 1. So we get the point 1 comma 0, which would be located right here. So I'm going to take that point 1 comma 0 and that point at 0 comma negative 5 and simply draw a line that is going to connect those together if I can. Let's see. Now notice that I'm drawing my line dashed, and the reason that the line is going to be dashed in this picture is because it's a less than, as opposed to say a less than or equal to, which would mean that we'd have to go up to the line. Okay, second part of the problem is to determine which side we need to shade. So the way I recommend doing that is by choosing a test point. Now the test point, if it's allowed, the best point to check would be 0, 0. It's always convenient to use zeros when you're working with linear equations and inequalities. So notice that if I go back to the inequality and I replace x with 0 and I replace y with 0, I get 0 minus 0 on the left, which is 0, and just a 5 on the right. And notice that 0 less than 5 is a true statement. So my testing point right here happened to be a true value, and therefore the shaded part of the graph is going to be the side where 0, 0 is. So we shade, in this case, the upward part of the graph, the part above the green dashed line. So again, the 2 steps are usually graph the line as a border, then test a point to determine whether you shade that side, or if not that side, then the other side. Why don't you pause the video and see if you can do the following problem on your own. Assuming you gave it a shot here on some scratch paper, let's do it together to see if you get a similar answer to what I get. So if we pretend that this is an equation and replace x with 0, you would get 2 times 0 plus 3 times y equals 6, 3y equals 6, y equals 2. So first point would be 0 comma 2. Then if we were to replace y with 0, we would have 2x plus 3 times 0 equals 6, 2x equals 6, and x equals 3. 1, 2, 3. This time, when we draw the line, we're going to draw it solid because our inequality is bigger than, but also equal to. So it's not a one-sided inequality. We're going to go all the way through and make a solid line, and then put on the tails. And then for our test point, we'll take 0, 0 again because we can. And notice that 2 times 0 plus 3 times 0 bigger than or equal to 6 would say 0 bigger than or equal to 6. And this time we are false. So exactly where that testing point is, that's a false place. And so since it's false, this time we would shade the other side of the line, the part that is above.